recording. So let's look at the what we did for these three functions and the inverse of you know of these functions. And the journey we have made is surely very, very important. If you understand all of these details, right, the devil's in the details, there's no way you are going to lose any point on these things. Okay, however, if you don't, you will lose point here and there, okay, along the way. Okay, so I spent some time trying to mark these curves, and I haven't completely finished, but I have done majority of it. I've done majority of the work. Okay, for example, right now, do you see the sine, the arcsine curve that we did, right? So the picture, right? The picture, you can get it so easily. It's right there. You just have to be able to use it. All the information you ever needed, they're in the picture. If you see the picture, you don't know how to get the information, you don't understand it. It's that simple. It's very, very simple. You just have to go down to the basics and make sure you you know you get it. And what are the perspective for getting those things, right? So I'm trying to get this sine to be closer to the curve. I spent a lot of time doing this because if I use these two softwares, it doesn't, you know, the marking is not that it's not permanent. It will move about. So so let me just give me one more second so I can get that done correctly. Okay, I think I'm just a perfectionist on these things. Oh, how come it did go there? Never mind. But anyway, so I wish you guys to write it down, all of these details, and understand, right? For example, I'm going to go over on this picture to recap. How do you read that picture, right? Everyone, I believe that every one of you will have that. Let's see, make it to 0.9. Let me put negative 0.9 there. I should make it. Okay, there. Okay, it's not perfect, but it does the job. For example, if you look at this picture, right? If you look at this picture, we're going to talk about, look at this picture and or the unit circle. Which one do you want to do first? Unit circle or the curve? We're going to do both, right? We're going to do both. Okay, so let's dig out that 1,000 words. 1,000 words. A picture is worth 1,000 words. Okay, now you can see from the function perspective, the input is what? The input is horizontal, right? The output is vertical. That has never changed. It's never changed since elementary algebra, since you were first introduced, you know, the Cartesian system or rectangular system. Has never changed, okay? It's just the input, right? On the sine curve, you can see pi over 6, that's the input. The output is a ratio. Pi over 3, the output is √3 over 2. Pi over 2, that's the ratio is 1. And on the other side, when the input is negative pi over 6, the output is negative half. When the input is negative pi over 4, which is right here, I didn't mark these two because they're just too crowded, okay? I want to be illustrative, but not so jammed, so that you cannot see it. But I use the color tone. And you guys should be able to do this all by yourself. That shows you understand. That shows you understand. If you cannot say, if after the class and I'm drawing the curve, I cannot plot these points, then you don't. Okay, that's a simple self-check. That's a simple self-check. And then if you cannot do it, what do? You listen to the lecture again. You just come back to watch it and just make sure you really understand. It's all about input, output, input, output, input, output, input, output, input, output, input, output. In your previous experience, it's probably x comma y, x comma y. X comma y is not enough. Okay, because in the case of sine, the input are angles, the output are ratio. Okay, what is the ratio? Y over R, right? We go by the definition. In the arc sine situation, the input is ratio, the output is what? The output is angle. You see, they're all right here. They're all right here. You see the difference? So that's why this semester, instead of using x comma y, I don't use x comma y. I use input output. You will see this will tremendously benefit you, even when you're doing programming. Okay, I'm sure you're heading that direction, right? Most of you guys in STEM major, right? You have to do some coding. In coding, it's all about that. Input, output. What's input? What's output? What's the nature of input? What's the nature of output? If you're going to be a trader on the stocks, then you will also see that your curve on the stock market is about input, output. No difference, no difference. All right, so these two curves, one is arc sine, which is in red, and the other one is a dark color. And you can see that relationship, right? On the black curve, this is sine curve, okay, which I marked over here, okay? Ideally, I will mark more places, but you know this is sine curve. The red one, I didn't mark it because it's kind of crowded, so I just assume you know it. Okay, this is arc sine. You can see when it comes to know what is the domain, what's the range about sine, for example. Okay, about sine, for example. Okay, so you can see, you can make a box. You can make a box. You can make a box. For the black curve, is actually, you cannot box it horizontally. Do you guys see that? You cannot box it in horizontally because it keeps going. Sorry. Let me get the arrow that works for me. There. In this direction, it keeps going, right? So that's negative infinity. That's negative infinity. And in the other direction, it keeps going. Okay, so this black box does not box the domain of sine. Okay, I'm just using this as an example. This keeps going, and that goes to where? That goes to positive infinity. Goes to positive infinity. Okay, that's horizontal. Horizontal indicating the domain is from negative infinity to positive infinity. Do you guys follow me? Okay, that's a sine curve. Do you follow me? That's the horizontal concept. Horizontal concept is the input. So input for sine can be from negative infinity to positive infinity. Then of course, I know you know that. You know that. But I'm using this for latter examples, and you can see how consistent they are. How consistent they are. Now, so let's look at the vertical. Let's look at the vertical. The vertical direction, sine curve is boxed. There's a limit. It doesn't go higher than 1. It doesn't go lower than -1. So here you see the -1, that's a +1. Do you guys follow me? So the curve is bouncing between -1 and +1. It never go beyond -1, never go below -1, never go above +1. So that's the range, which is right here, which is described mathematically right there. You guys follow me? So please write it down. So this is a visual, okay? So when you see that picture on your, whatever your, most sophisticated calculator, right? Ideally, this class, I have given you homework. I have given you the homework, asked you to plot those points, right? And you are expected to do it. But if you don't do it, I'm not going to go to your house to say, oh, hey, Bailey, did you do it? I'm not going to let you knock at your door to check on you. It's entirely your responsibility. You're responsible for yourself. Guess what the benefit of doing it? The benefit of doing it is going to be in your head. This curve will be in your head. Okay, you never have to spend a lot of effort to try to memorize it. And you probably don't even have to be reliant on the calculator. Okay, that's the benefit of doing it. That's the benefit of doing it. Okay, so that's about domain and range. Will you be using these range for sine in calculus? Absolutely. Okay, if you won't get to use this next semester, you don't use this, please come back to tell me. Okay, I'll take you out for pizza. Okay, I'll take you out for pizza. Free, I pay for it. Okay, I'm too cheap. I don't have $1 million to give you. Okay, so that's a domain range perception. Do you guys follow me? That's a domain range perception. Now, did you write it down? All these points? Okay, all these points I put here, these are this will be let me tell you what these exercise is corresponds to. Okay, these corresponds to the exercise. This I give you as a homework. I give you the homework. The homework I give you, these corresponds to the homework on Trig 2A, 2A, Trig 2A, Trig. The double A are optional, okay? But if you do it, it will be good for you. Trig 6A, Trig 6AA, Trig 6, triple A. Better yet, if you do 6B, that will be, that for cotangent. I didn't even ask you to do that. Okay. So these corresponds to the homework questions. These are corresponds to the homeworks. Okay. Of course, you can also say, it corresponds to, you also see those other homework questions on Trig 4A, right? They are related. Trig 4A, Trig 4A, Trig 5. Okay, so if you understand all of these points, you should not have any problem doing those homework exercise. If you do, those are telling questions that give you feedback, that telling you, hey, you don't understand everything here. Okay, you're gonna lose points somewhere. Okay. Now, did you write all of these down? Yes. And then we're gonna look at the arcsine. Then we're gonna look at arcsine. How do we tell from the picture? Did you write down all the details? The devil's in the details. Okay. Now you should understand why I emphasize what the nature of the input, especially for trigonometry, for trig functions, right? Sometimes you only just have angles and ratio. Either angle are the input or ratio the output, or vice versa. You only have these two situations, really. You really just have these two situations. Okay, so can we move forward? Okay, so that's the sign, right? So the picture tells you 1,000 words, to tell 1,000 words. Now, I'm gonna clean this up. Okay, I'm gonna clean this up. Let's look at the arc sign. Let's look at the arc sign. How do we see it? Domain, range, right? Domain and range. Now, I have already indicated the exercises, earlier. So, I'm not gonna do it again. I'm gonna box it, this time with the red. Okay, the red. Arc cosine is in this red box. What does it tell you? And I will also talk about what is so important about domain and range. Okay. This red box is about arc sine. Horizontally, the horizontal span. What is a horizontal span? Between -1 to +1. You see, it tells you the input is between -1 to +1. So this horizontal span right here, okay, this horizontal span, it tells you the domain right here, or right there. Do you follow me? How about the vertical span? The vertical span, okay, let me change your color. Green. The vertical span. The vertical span, it tells you the range. It tells you the range in all these different forms. Okay, so if you go back to look at those exercises, I put them there. Sometimes the order is, it's not the same order, and of course you have to use ARD, right? So sine is ARD, arc sine is DRA, right? We understand that, DRA. But arc sine is much confined to this box, domain and range. What is so important about domain and range? Your solution, okay, about input or output will never be outside domain range. Our solution, your solution, my solution, okay, our solution about input output. Sometimes we need input to be the solution. We're given input, we're looking for output. The output will never be outside the range. Sometimes the output is given, we're looking for input. The input will never be outside the domain. That's why knowing domain and range is so important. Knowing domain, you know what qualifies to apply the rule, and knowing range, you know what to expect. Okay, that's the power, domain, and range. In calculus class, domain and range is supposed to be following you everywhere. You always need to be aware of it. And on top of that, you're going to learning new concepts, new theorems, and stuff like that. Okay, so how's my picture? Is my picture clear, or is my picture confusing? If my picture is confusing, I'll do it again. Right? Horizontal span, vertical span. Okay, then you say, how about this new function? This new function usually is not very useful. Okay, I said it's rarely used, but it is used to certain degrees. You still have to understand that. Today we're going to talk about that. Okay, so we're going to do the recap, and then we're going to talk about the use of this rarely used for new function. Okay, did you write it down? Could I move forward? Okay. So let's look at cosine. Once you understand sine, oh, wait a minute, I haven't given you the unit circle perspective, right? The unit circle perspective. The unit circle perspective, we understand how the graph is made, right? The arc length measured from the standard position to the terminal, and that's the input, right? ARD. Next is that when you're looking for sine, when you do ARD, you can get all those blue numbers, right? And beyond. Okay, just remember, between the blue numbers, there are other numbers out there. Okay, there are other numbers out there. Okay. Arc sine, however, for processing arc sine, you know, I'm not spending too much time on sine because everybody know how to find those values. For arc sine, you just drop off the second and third. So you go from DRA, and the angles are also measured. The angles are measured from standard position. For positive ratio, you get a positive angle. For negative ratio, you measure it clockwise. You follow me? And this is similar to tangent. We will get to it. Any questions? Everybody, so let me look at the chat. Okay, if you have questions, okay, and if you, let me see, there's certain people, is he here? Okay, if you have questions, okay, so please don't hesitate to send me the chat message, or even either private or public. Okay, since we didn't make it to the either appointment or, you know, or office hours. Okay, so that's the unit circle perspective. So the unit circle for arc sine is DRA. Okay, any questions here? I'm waiting. Any questions? Please don't hesitate to ask questions, because your question may not just helping you, it could help other people as well. Okay, so let's look at cosine. Okay, so I'm going to clean this up, and let's look at arc cosine. Cosine and arc cosine. Okay, this is a cosine. Cosine, if I make this picture just a little bit longer, okay, I'm just going to extend the view a little bit, right? Make it to from -5. Okay, so that's the curve. I'm just going to make it a little bit longer. And you know the domain for cosine, right? The domain for cosine. What's the domain for cosine? Everybody knows that, right? Yes? Domain for cosine. So it is, let me start from here. I'm gonna still draw that box. Okay, I'm gonna draw that box. I turn into green. Okay, turn green. I'm going to change to black. Oh, it doesn't change. Okay, let me do it again. Okay, I'm going to draw the box. You see cosine is boxed, but this doesn't contain it because in this direction, it goes to negative infinity, and this direction goes to positive infinity, right? So these goes to negative infinity, and this goes to positive infinity. Positive infinity. So when you see this horizontal span, okay, the horizontal span, it's forever. Okay, in both directions, it goes out. Oh, hold on. My drawing using this, let's see, using this software there. So it goes outside. You see, that's why cosine takes angle as input, and on the unit circle, those red numbers, and the numbers between the reds. Okay, there are lots of numbers between the red. Remember your first quiz, quiz number 4, right? Quiz number 4. I deliberately give you a situation that's not a special angle, and those ratios will come too. There'll also be red number, blue numbers. They're not the special angles. Okay, so those numbers will count too. So there are infinite number of numbers between the red and blue. Okay, but the range, okay, the range, I'm going to use green in between. Why am I using green? Okay, I can use green. Okay, that's the vertical. That's between -1 to +1 right here. It's actually, I covered it. Okay, you know cosine range is between -1 and 1. Okay, so it's underneath it. It's underneath it. Do you follow me? Does everybody follow me? Yeah? Now, that's the domain range about cosine. So let's look at the arc cosine. Are you ready? Arc cosine. Okay. So I'm going to scoot over just a little bit. Okay. I'm going to scoot over just a little bit. Include all of these stuff. Okay. Arc cosine. Arc cosine, once again, if you look at the box, that tells you the domain and range. Okay, domain, horizontal span from -1 to +1. Range, what does it tell you about range? What does it tell you about range? Between 0 to pi. So arc cosine value will never be negative. Do you see that? Arc cosine value is always between 0 to pi. Remember I mentioned that domain and range tell you, okay, any question about domain, about input will never go outside the domain. It should never go outside the domain. Any questions about the output should never be outside the range. Okay, that's what domain and range tell us. Domain tell us what can be used as input, and range tell us what can be expected. What can be expected, okay? Now, so this red tells you cosine is bounded vertically between 0 to pi. Arc cosine will never be, arc cosine of any input, qualified input between -1 and 1 will never be a negative angle. Okay? Now, there's a new function, truncated. We're going to talk about it. It's rarely used. Okay? So any questions so far? I'm going to just remove these boxes. So maybe you want to write down the points. I did not mark many points. Okay, I marked a couple points. Okay, and there's all these line of symmetry, y equals to x, and I haven't get time to mark, but I think it should be easy for you to mark. Okay, and the next one we're going to move to tangent and arctangent when you're ready. Okay, feel free to mark some more points. Okay, because that's in your homework. Okay, if you have any questions, any issues, please let me know. Okay, you need to know how to mark these points. Where does it start, where it ends, and one-to-one function. You can see the properties are absolutely consistent. That's why we emphasize, these key concept, function, one-to-one function, right? These two key concepts. Okay. We didn't use very much of increasing, decreasing function yet. Okay, of course you can, okay? But you get a lot of those elaborations in calculus classes. All right. Are we ready to move on? Okay, tangent. Okay, tangent. Tangent curve, I did a lot of marking. This is a very important function you're going to use in calculus classes. Okay, especially calculus 1. Okay, I made some adjustment. Can you guys see clearly about these markings? I'm using this software to mark everything. So when it doesn't disappear. Okay, it doesn't disappear after I close the Zoom or stuff. So it's going to be there. Okay, there's a lot of details out here. Okay, and these ratios, of course, is a tangent ratio. It takes angles, but not any angles. That's a domain, right? The numbers not in the domain, they are marked by these vertical asymptotes. Okay, and what are the line equations of those vertical asymptotes? I put them there. This is x is equals to negative pi over 2. This is x equals to pi over 2. Can you guys see that clearly? Yes? Can you see that clearly? If you cannot, I can make it just a little bit larger. 130%. Is that better?
Yes.
Okay. So for tangent, is difficult to make a box because the box will be chopped. It's going to be chopped, right? There's one box here, one box there, one box there. So I'm not going to use box. So you can see those vertical asymptotes for tangent, and you need to know how to write down their equations. Okay, this one is x equals to negative pi over 2. And this vertical line is x equals to pi over 2. Any questions about that? Okay. And the range of a tangent is what? The picture tells you. What does it tell you? From negative infinity to positive infinity. The picture can tell you because you can see it goes to, right? In this direction, it goes as high as possible. In this other direction, goes as low as possible. Okay, so that's why the range is from negative infinity to positive infinity. And we went through the truncation process, and we know that the inverse function, which is the red, right? You see, I marked all these points. We marked it in class, but it disappears. But I'm sure you have it, but I just want to make it permanently printed here. Okay, you can see the inverse function property. You can see the inverse relationship, right? This red piece with one of the pieces, When we talk about tangent, we talk about the tangent curve right here. But these two functions are not inverse to each other. They're not inverse to each other, which is obvious from the picture, right? Now, the line, the red broken line, we have a red curve and red broken line, a broken line. The red curve is, of course, is arctangent. Domain is all real numbers. Domain is all real numbers. A range, give me the range. All right, I have to make some, I'm gonna make it a little smaller, okay, 120%. Okay, domain. Domain for arctangent is from negative infinity to positive infinity. We can box, we can do the box now for arctangent. Sorry, I pressed the wrong button. Do you guys see the share? Okay. So, of course, this box doesn't contain it, but at least you see the arctangent is, the box doesn't contain it. So in both directions, okay, it goes beyond the domain for arctangent. See the red? From negative infinity to positive infinity. Do you guys see that? The range, however, what's the range for arctangent? I'm going to use the green. Between negative pi over 2 to pi over 2. Okay, which is right here, right there, right there. Okay, right there. Domain, arctangent, domain is all real numbers. Range is between negative pi over 2 to pi over 2. And what is more, as x approaching positive infinity, arctangent approaches negative pi, approaches pi over 2. As x approaching positive infinity, arctangent approaches negative pi over 2. I will write that down for you, okay? After you copy all of these. All of these little details, okay? Of course, when you do your homework, you're gonna mark more points. You can mark more points on the curve. Everything is in the picture. You really don't need to, right? A picture covers all of those homework questions for arctangent. That means it cannot touch negative pi. Of course, never. Never. That's why it's broken lines. That's why broken lines. Never touch them. But it gets infinitely close to it. Okay? Gets infinitely close to it. Okay? Do you understand what is infinitely close? Infinitely close, in my view, with today's technology, it cannot do very good job. I do see some program trying to depict infinitely close, but I think we human beings, we have the capacity to imagine that. So you just imagine infinitely close, okay? So you imagine this red curve we'll get so close to the broken red here. Do you guys follow me? Get as close as possible. Okay, so after you write this down, I'm gonna elaborate on this one. Okay, did you write it down? Did you write everything down here about domain and range? Okay, so now let's picture infinitely close. Okay, let's picture infinitely close. You see, as this piece, okay, this piece, okay, what does it depict? It depicts as x approaching infinity. Okay, the curve, okay, arctan will be approaching pi over 2. This red curve will get infinitely close to the broken red line, broken red horizontal line. Do you guys follow me? That's what this picture depicts. Follow me? As x approaching positive infinity, you literally see this being written in your calculus textbook. Now, let's look at the other corner. This corner, and of course, infinitely to the left. What does this depict? Can you write it down? As x approaching negative infinity, arctan x will be approaching negative pi over 2. So this piece tells you that. Okay, in calculus class, of course, you're going to use limit notation. You're going to use limit notation. I wish someone told me that before I took calculus class. Okay, infinitely close. Okay, as close as possible, as close as possible. I think that can only be a vivid imagination in human mind. Okay, technology can simulate to a certain extent, but it will never simulate to its perfection. At least I haven't seen it. I have not seen it. Okay, of course, what I have seen is very limited, right? The technology today is just amazing, right? The development is amazing. Okay. And can never touch it. Can never touch it. You see, did you guys see the comment by Cortland on chat? It's a very good comment. Never touched it, but the only thing is that he put a question mark. The question mark should be removed. Never touched it. Never ever touched it. In particular, actually, arctangent, you can see it's an increasing function, right? It's an increasing function. It has all those interesting properties. Okay. And tangent is increasing on different pieces, different intervals. So if you apply these concepts, you can see that. But I'm not going to elaborate too much. Okay, I want to be more focused. Okay, so that hopefully will help you understand these two inequalities. Do you follow me? Okay, so are you done writing it down? And now we're going to get to today's task. Okay, we'll get to today's task. All right, get to today's task. Okay. All of these, remember, all of these we just covered. They all derive from definition. Nowhere else. Nowhere else. You don't need to look elsewhere. Definition. With definition alone, they derive all of these. Tell you domain, range, curve, everything. Everything. Don't need to go elsewhere to look for them, to look for the source, right? Where does it come from? From definition. Okay. So next important property, like I put at the very bottom, on the very top. Okay, on the very top of today's lecture. Okay. Remember this property we talk about? A function with its inverse. We talk about this when we were doing the 2 to the power x and log base 2x. Remember we did that, right? And it is also true with e to the power x and ln x. They are inverse function to each other. Okay, so I'm going to put the green here. I think I probably will never make it perfect the way I want it, but at least you see that this is e to the power x, this is ln x. They're inverse function to each other, right? At the time we talk about this property, didn't we? We talk about this property, that a function that are inverse to each other, right? Function that inverse to each other, they have that property. Composite. Okay, and will this property apply to the trig functions? Yes. Okay, so I'm going to show you. You understand we have done the logarithm function and exponential function. If you have questions, go back there. Okay, if you have questions, reach out to me. If you still have questions, reach out to me. So now I want to take this property to show you how it is applied to sine and arcsine, and to whom it applies to. So this property. Okay, this property applies to, in our case, apply to these two functions, because they are inverse to each other. You follow me? They are inverse to each other. Does everybody follow me? It doesn't apply to these two because they're not inverse to each other. It applies to these two. And how is it being written? Okay, so I'm going to show you. Okay. If I call f, okay, being the function we call arcsine, okay, f inverse is the function we call sine. But the sine, we have to specify their domain and range. Okay, so what I'm going to do is that I'm going to take only this piece and put it over here. Okay, so then I don't need to. So just forget this for the moment. Okay, you're gonna have plenty of time to work on that one. Now, domain and range. Domain and range. Do you follow me? So this will be the f of x. And this guy is f of inverse of x. These two functions are inverse to each other. One's domain is the other's range. Do you follow me? So I have this assumption here. Now, let's see how that will turn into in the actual function. Okay, what would this be turned into under the circumstances? Okay, does everybody follow me? We did the truncation, we did all of that stuff. We know that these two functions are inverse to each other, and they will also satisfy the common trait of all functions that are inverse to each other that satisfies. Do you guys understand? It's under that umbrella. Okay, so for f, okay, because I assume f is arcsine and f inverse is sine, and of course with restriction, this sine domain is from negative pi over 2 to pi over 2, okay? I'm going to remove this because I'm going to use that, okay? I'm going to make it a new function, okay? New function, okay? Which is different from the sine we know because it has a different domain. And these two functions have one's domain is the other's range, right? We have all of that satisfied. So now let's see what is sine. Okay, so this guy is arcsine. Okay, so when we translate this piece, okay, this pretty much is, this is f of that, right? And this other one is this, okay, by definition. Now, since f is arcsine and f inverse is sine, so that would be true. But only for which sine? Only for this sine with that domain. Does everybody follow me? And next one, and this will be sine, and f is arcsine, and that will be the x. But this sine, okay, this sine over here, there's an x here, and this x has to be from where? This x has to be from where? So when we apply that property, when we apply this property, which also apply to, you know, e to the power x, ln x, right? Or any pairs of function and its inverse, apply to our situation, it becomes this. This is the first property on trig on your note. Please look at your note. Trig 7a. So please look at your notes on trig 7a. I don't know what the page number anymore because I'm looking at this older version of the printout. Do you follow me? Did you find it? Did you find it? Did you find it? Trig 7A. I don't think I changed the number, the page number. It's going to be probably around the page 40-ish, after 40. Because for the new handout, I added some new stuff.
I got it on page 67.
67, thank you. Page 67. Thank you, Mikhail. Is that Mikhail? Is that Mikhail? Thank you. Page 67. You see on page 67, there are two big boxes. Okay, the box on top, the box on top, the first row is exactly the property I wrote there. So this is true only under the condition, because they don't want to mention the other the rarely used function. Remember, we don't want to confuse people, right? We don't want to mention that rarely used function. Therefore, we specify the domain here. So this is only true. So how do we read these properties? If you know how to read these properties, it can be very useful for us. So today we're going to go over Trig 7A, okay? When we go over Trig 7A, everything we learned so far about trigonometry and everything we learned so far about function, inverse function, they will come to us. They will come to us. So this will be really good exercise to check on us if we understand, You follow me? Okay, these are the first row, you know, the order is reversed, which is, I hope that doesn't bother you. You follow me? So next, let's look at cosine. Okay, let's look at the same property. Okay, the same property as applied. And you realize you may feel, oh, this is a lot to remember. No worries, okay? If you understand what we have covered so far, you understand how the constraint is being set up. You don't need to memorize much at all. You don't need to memorize much at all. All you have to know is what kind of input is this for the input. The input should be angle or the input should be ratio. Okay, for this input, okay, for this input, oh, never mind, don't do that, please. Okay, this input, okay, look over here, this input, okay, this input x, okay, follow me? This input x here is given to sine. Okay, sine is applied to x, and that x has to be what? Angle. Okay, how about this other input? What would that be? What's the nature of this input? Ratio.
It's the ratio.
That's right. Remember what I said? You look at a symbol. That symbol doesn't mean anything unless you look at the rule that apply to the symbol. Do you follow me? X, same name. Do you follow me? This X and this X, they have the same name, but doesn't really matter. Even though they have the same name, they mean totally different things. And this is the reason why from the beginning, I emphasize input-output angle ratio. Do you follow me? This X, the role of this X is determined by the rule that X on it, which has to be angle because sine takes input, take angle as input. This X, arc sine applied to it. So whatever value you give to this x will be judged by the domain arcsine allows, which this x has to be between -1 to +1. You follow me? So even though they have the same name, they don't mean the same thing at all. They're not even in the same category. They're not even in the same category. You follow me? Right? Remember earlier on, we have a question, right? I forgot who asked this question or I raised that question. Can we say because of this, we say, oh, because they both equals to x, right? Could we say because they are all equals to x and x is x, right? Can we say this is true? Who do we say that? Who do we? Yes or no? Look at the examples we have here. Who do we say that? Can we say an angle is the same as a ratio? Of course not. That is wrong. Okay. Wrong. Completely wrong. Do you follow me? Symbols are just placeholders. If you think that mathematics is abstract, yes, it is abstract. However, it's very consistent and rigorous. Symbols usually just a placeholder. You can use any symbol, right? We just happen to use XY. But what is X, what is Y? X is usually the input and Y is the output. Furthermore, you don't have to use XY. You can use the heart, you can use, triangle, you can use, spade, you can use a flower to represent, right? In human history, we use flower to be some kind of metaphor for whatever, right? And we're not, there are all kinds of things in the area of art history. They use symbol to represent certain things. And in math, we do that too. But we are very consistent because we apply our rules. Okay, our rule determines, whatever symbol the rule applies to, the meaning of the symbol. Do you follow me? Okay. The symbol X, its property is decided by the rule that applies to it. Okay, once we understand that, are we ready to move on to cosine? Yes or no?
Yeah.
Okay. Clean this up. Okay, this is wrong. Okay, so I'm going to make a comment here. Wrong. Okay. Okay. All right. So let's move on to cosine and arc cosine. For cosine and arc cosine, the same property still applies. Over here, the same property applies. The same property applies to what? To these two functions. Okay, remove that one. These two are inverse to each other. These are inverse to each other. Okay, so we're gonna apply, how we're gonna apply this? We're gonna call this guy F. And of course, this will be F inverse. And they are inverse to each other with a specified domain and range. You guys see that? These two functions are inverse to each other. When we apply this property, of course it applies. Okay, and this property, of course, turn into what? Turn into that property, right? We just apply the composite function. Right? So let's see what do we get? What do we get? Right? We will get F is arc cosine. Arc cosine. F inverse is cosine x. So that equals to x according to this property. But this cosine has to be this cosine. Okay, so for this x, it has to be between what? It has to be between 0 to pi. Therefore, it's between 0 to pi. That's the second row on trig 7a. Do you guys see that? The next one. The next one. Okay. So this is one. And there's another one. Cosine. Okay, because that's a cosine of arc cosine x is going to equal to x, but this x has to be from here. So these are the other two properties on the second row. You guys follow me? Okay, trig 7a, second row. Trig 7a, second row. Okay. Why these restrictions? Because it actually refers to the new function, the domain of the new function. But we don't want to use it explicitly, we don't want to confuse people, so we wouldn't put this restriction. Make sense? Does that make sense? And once again, this input is angle, and this input is ratio. Same thing. Okay, so let me just be a little bit lazy a little bit. Okay. And this x, that's angle ratio. Okay. Does everybody follow me? Now, what do we have done here in these past weeks? It has been intense because you have to be closely following me. And I will be quizzing you left and right about these things. For sure. Excuse me. For sure. And you'll be examined on midterm exams intensively, heavily. If you miss some bits and pieces, you may have a hard time to follow. I agree. You need to watch the lecture over and over again, maybe go back to your trig days and to review those. Because what I put here is very concentrated with also with some new perspectives, with some new perspective. These new perspectives are essential for your success in calculus classes. Okay, so now, did you get this one here? So are we ready for tangent? Okay, so we got the second row. Let's look at the third. Once again, you understand where we're heading, right? We're applying the same properties. Applying the same properties for tangent, arctangent. Right? Same thing. But this time I'm going to remove that tangent that we're going to use forever for the moment. Okay. And we're looking at these two functions that are inverse to each other. These two functions are inverse to each other with their specific domain and range also satisfy these properties. That's, for any pair of inverse functions. No exception. No exception. You can see the consistency of mathematics. Okay, so how many definitions we have dealt with? Definitional function, one-to-one function. That's all. Only two definitions derive so many powerful things. And of course, along with definition of trigonometry, which is ARD, along with that, derive so many powerful things. So this time I'm going to call this F, and this is F inverse. With that specified domain, of course. Domain and range is more like the shadow of the function. You mention a function, you have to know its domain and range. It's like we all have shadows, right? Everybody has a shadow. Sometimes it's visible, sometimes it's not visible. Domain and range follow the rules all the time. So when you talk about a function, you have to know its domain and range. Okay, so now in this case, let's see what do we derive. Okay, F is arctan. F inverse is 10. It's going to be equals to X. But this X, this A, which is in the place of A, is being constrained. It's in here. So this condition has to be attached. You follow me? So this is a condition has to be attached. And of course, in this case, the input is, what kind of input is this? I want you guys to think about this.
The input's an angle.
That's right. Perfect. Perfect answer, right? That input is angle. Now let's look at the next one, right? And this time, F inverse is arctan. And F of X, I'm sorry, this is 10. My bad, okay? Because F inverse is 10, right? And F is arctan X. And this should equal to X as well, because they're inverse function to each other, right? But this time, is there a condition attached to it? Arctan. Arctan, what's the domain? All real numbers. That's like there's no condition, right? X can be any real number. So this condition really tells there's no, it's unconditional. This actually tells unconditional. It doesn't matter what ratio. It doesn't matter what ratio. I know it's hard to memorize these things. You only have to understand. You only have to understand. Okay, there's no way you can memorize this and never make a mistake. Okay, impossible. I cannot do it. I cannot do it. This ratio can be any real number. This ratio can be any real number. Okay. So this statement is unconditional. All the other statements, they're all conditional. They're all conditional. Last but not least, since we didn't do cotangent and arcotangent, so today I'm not going to do that today because I want to concentrate on practicing these properties. Okay, these properties, which are, they're all there. And we're running out of time. We have like 15, 16 minutes. Okay, so what I like to do is that I'm going to take these to the top, and we're gonna work on some stuff. We're gonna work on trig 7. Okay, trig 7 is a section we must work on. Okay, so I'm gonna copy and paste some stuff and we put it on the top. Okay, of course I'm gonna trim it. Okay. Oh wait, why did I copy that again? Tangent. Okay, here. Sorry. Over here. Copy. It didn't copy earlier. Okay, paste. Okay, so that's the last one, sine. Over here. Okay, now you have all the tools. Okay, feel free to use your notebook. So I'm gonna scoot them over a little bit. Right. Okay, so we're gonna take these properties, I'm gonna practice trig 7. Okay, so let's look at trig 7. Trig 7. If you have taken, I'm sure all of you have taken trigonometry class, okay, these sections were all covered. Why is it all real numbers? Which one do you refer to, Cortland? You mean arctangent?
For tangent of arctangent x.
Yes, because arctangent here is all real numbers. This domain for arctangent is all real numbers.
Oh, okay.
You got it? All you have to do is just go back there.
Yeah, I got it. Thank you.
Right? This arctan, the domain is all real numbers. The range is from negative pi over 2 to pi over 2. Exclusive. Okay? All right. So now let's look at some exercises on on trig 7. Trig 7a, sorry. Trig 7a. You must be exhausted by this time, are you? It's pretty intense. Okay? I would imagine if I were you, I need to watch the lecture over and over. I don't know about you. Okay? because what I have covered, the way I covered it, I think is definitely different from what you have learned before. So if you're kind of iffy, need review about what you have learned before, now you add this new perspective, it might feel overwhelming. There's no time to slack off. Okay, if you want to have a better time, a better grade in your calculus class, and work harder now is a good idea. Okay, work harder now is a good idea. Okay, so trick 7A. Trick 7A, let's look at the first one. Before we jump to the answers, okay? Number one. We have sine, arc sine, 3/5. What does this equal to? What does this equal to? Sine, arc sine, 3/5. This is not a special angle. This is not a special angle, isn't it? It's not a special angle. There are two ways to do this, at least. There are at least two ways to do this. Okay? Which way do you want first? The easy way or the hard way? None of them is easy. None of them are hard unless you understand, right? If you do it the way that from definition, of course we can do it from definition. Okay, I have this unit circle where I don't use unit circle. Okay, so we can use unit circle, but we don't have to use unit circle. So I'm going to give you another perspective. I'm going back to definition. Okay, I'm going back to definition. Okay, we have 10 minutes. I think I can, maybe I can kill this. Okay. I'm just go by definition. Okay. Anybody has any clue as to what should the answer be? If you do, and you're certain you're right, please don't tell yet. Please don't tell yet. Okay. I'm gonna be addressing to people who think, oh my God, I don't know what the answer. I don't know this answer. That's okay. That's what I'm here for. Okay. So once again, I get to show you the power of definition. Okay, so I'm going to put this unit circle aside. I'm just going to use my definition, my good old definition. Okay, what's the definition? Angle measurement, right? Positive angle, negative angle, counterclockwise, clockwise, reference angle, just ARD. If I do it from ARD's perspective, okay, if I do it from ARD's perspective, what will happen? I will have a terminal, right? The input for arc sine is this. I know this is going to give me an angle. This is going to give me an angle, right? Because this is a ratio. Arc sine takes ratio, produces angle. Okay, so I'm going to say, okay, let theta equals to this angle, right? Because I totally understand that arc sine takes ratio, produces angle. And this angle will end up to be where? This angle is going to be between what? Negative pi over 2, pi over 2. Do you follow me? DRA, because arc sine is about DRA. And the quadrants, I don't need these quadrants. Okay? And in particular, because my ratio is positive, And therefore, I know that this angle is not only from negative pi over 2 to pi over 2, it's actually between where? Between 0 to pi over 2. It's in the first quadrant. So my theta angle ends in the third quadrant, first quadrant. So, okay, I can draw my terminal. It's not a special angle, who cares? It's not a special angle, it's not a special angle, no problem. Okay, so this is my theta. This is my theta. This is my theta. Okay, and this theta, okay, this theta corresponds to the opposite, right? So I'm going to use definition. As a result, sine of theta would equal to 3/5. Okay, sine theta equals 3/5. Agree? What does that mean? That's the definition of function is inverse function, right? Oh no, you see, the two software don't talk to each other, right? The two software don't talk to each other. That's okay. I just have to redo it. Okay. Now, so this is a terminal. And that's theta. Right? Now, from this piece of information, I can draw the triangle. This will be the opposite. Okay. And so this is going to be 3. And this is a 5. Right? And of course, this is a 4, but I don't need that. I don't need that. So since I have introduced, since then, okay, let me use the dark color. Then, with that introduction, what do I get? This is a sine, and this is a theta. So this is asking for sine theta. What's sine theta equal to? Sine theta, of course, is 3/5. In this entire process, what do you think is the key information? The key information is here. The range of arcsine. Do you follow me? The range of arcsine. Isn't that important to know the domain and range? Of course, you need to know the domain as well. The domain is between -1 and +1. And the range is between negative pi over 2 to pi over 2. In particular, when the ratio is positive, the range is going to be, the angle is going to be terminating in the first quadrant. Measure from the standard position. It's a counterclockwise measurement. Okay, so what will be the answer here? 3/5. You follow me? Okay, so this is the first method. This you may regard as a long method. Okay, that's a long method. But what if you know that property? What property? Look at the property we just went over, right? Look at the property we just went over. Did you guys write this down? Okay, so I'm going to clean this up. What if you know this property? How about using this property? How do we use this property? what do we have here?
Uh-huh.
What do we have here? We have sine, arc sine, 3/5. And this property tells you if this ratio is between -1, it is always equals to x. And our x here is 3/5. That's it, you're done.
Oh, okay. That's
Did you
really
see
easy.
that?
Yeah.
So let me summarize this. Okay, we're running out of time, so I don't want to hold you any longer. We actually went through some pretty. So method 1, method 2. I told you at least 2 methods, right? 2 methods. So if you are aware of this property, you're aware that f, that property about inverse functions to each other. You don't need to do all of that stuff. All you have to do is check this condition. If this condition is satisfied, you can just apply. Do you follow me? Do you understand? So either method can be used. The first method requires you to know the range, of course, domain and range of arc sine. And the second method, you just have to know a little bit more. Either way, you end up the same place. Okay. Ooh. You should expect another quiz. Tomorrow we'll continue to work on Trig 7. So I'm going to assign Trig 7 as your homework today and do as much as you can. Really try some of those. You actually have all the tools already to do it yourself. Okay, so I expect you to bring a lot of questions tomorrow. Okay, tomorrow is Thursday, right? Another week is going to pass very quickly, very quickly. Okay, there'll be, about arc sine, arc cosine, there sometimes is mixed together. Okay, the method we talk about here, however, is very, very important and very, very useful. You will find yourself still using these methods, like, using definition, draw the sort, like what we did earlier for this method, right? Using definition, draw the triangles, and using those, you will find yourself still using that in calculus 2. Okay, so don't be surprised. Don't say, oh, I never learned this. Well, you might have forgotten. But they're not going to go away. They are not going away. Okay? All right, so I will see you guys tomorrow. I'm looking forward to. And so please do feel free to ask me questions. And we will try to work out some time to work together if you need appointment, but please do keep the appointment. Okay, of course, and we also can remind each other. Okay. I will see you guys tomorrow. I'm going to open up the office hour today. Okay. Bye. Thank you. Good job. Good job.